All right, welcome to Practice Test Chapter 8 from 2021. It says each one of these is an inverse variation, which means x times y is equal to k. So this times this has to equal this times this. So 4 times 5 is 20. That means k is 20. So 10 times x has to also be k, which is 20. Divide, x is equal to 2. So that's the missing part. So there's a 2 there. 2 times 10 is 20, 4 times 5 is 20. That's what that means for inverse variation. Notice x became smaller, which means y has to become bigger. That's the whole inverse variation thing. So for example here, 3 goes to 5, it's bigger, so 8 has to be something smaller. 3 times 8 is equal to 24, that's my k. So 5 times y is also equal to k, which is the 24. Divide by 5, and we get y is equal to 24 over 5, divided on the calculator, and we get 4.8. Negative 3, negative 3. So I've labeled my 3 points, and that's the graph. Okay, now I'm going to put this one in, so make sure you put the parentheses around here. And here we go. So y equals 2 this time, divided by x squared, and then minus 9, parentheses. So what's happening here is x can't be positive or negative 3, because if you square 3 or negative 3, it's going to cause division of 0. So we go over 3, and it's going to put a mark here, and then negative 3, it's going to put a brand here. And then also, anytime there's a bigger x on the bottom and versus no x on the top, it's going to create this horizontal boundary there as well. So it's going to be in 3 parts here, the 3 different parts. Okay, graph. So it has this kind of shape here, the shape here, and an upside down parabola kind of thing there. So I'm going to put in 0 for trace and 0. 0 gives me negative 0.222. So 0, that's the point I'm going to label 0, and then negative 0.2 repeating 2's. And then it does this upside down curve here. So that's what it looks like there. It's kind of flatter than what I made it be, so it's kind of more. It's going to be bounded in this area, so I'll put in 6. That's too much. 5, 4. I'll do 4. So 4 over and then up hardly anything. So it curves here. So that's 4, 0.28. And then I'm going to put in negative 4, and it's going to be the same symmetry. So negative 4, negative 4 would be the same point. So negative 4 right there, and it curves like so. So I go negative 4 and positive 0.28. And change, right, because it's never stops, never repeats. So here's the curve here, the curve there, and the curve there. The only thing is I should have made that a little flatter looking. But that's the general idea of what this looks like. Okay, question number 5, it says simplify the fraction. We simplify fractions by factoring. So there's a common factor of 5 here, so it comes out. And then 5 right there. Then we know 5 divided by 5 is 1. So the answer is x plus 3 over x. We simplify the next one by factoring as well. So we do the 2 sets of parentheses, put in x in each. The bottom factors into the difference of 2 perfect squares. The top factors into positive 3 and negative 1. Yeah, that's how it'd be, because it has to be a positive 2 in the middle. Those cancel out, so it's x plus 3 over x plus 1. All right, the next one, we're supposed to state the restrictions and multiply. So when we multiply this one, we're going to factor it first to simplify it out. So the common factor there is 2. So x minus 5 would be left. this would be x plus 2 times x minus 3. And then there's a common factor of 5 there, so we so then the x minus 5's cancel out. But before we do that, we're going to state the restrictions. 5 minus 5 would be 0, and negative 2 would be 0 there. So x cannot be x cannot be negative 2, x cannot be 5. And then we hack these away. So we're left with 2 times this parentheses and 5 times this invisible parentheses right there. So the answer is 2x minus 6 over 5x plus 10. That looks right. Okay, now we're going to multiply here, and so this is all factoring. 2 sets of parentheses, put an x in each. Lots of factoring. X and 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 x. 5 and 2, negative 5, positive 2. 2 and 3, negative 4, positive 3. Positive 5, negative 4. That would be 1 in the middle, that's right. That'd be negative 1 in the middle, that's right. That'd be 5 in the middle. That would be negative 3 in the middle. Okay, just double checking to make sure that I have that correct. Now we start hacking away. These go away. It can be diagonally from each other or directly above and below each other. So these go away, these go away. And so we're left with this. That doesn't cancel out. X minus 5 over x plus 5. Now in my hurry, I forgot to state the restrictions. They come from 1, 2, 3, 4 spots here. So x cannot be negative 2. X cannot be negative 3 because negative 3 plus 3 is 0. X cannot be negative 5. X cannot be 4. So that would be the answer on that one there. Okay, moving on to division. The restrictions for division are weird. The strict restrictions for division come from 3 parts, right? So this can't be, this part here can't be 0 and 0 and 0. Okay, no, none of those can be 0 because that would be dividing by 0. If that was 0, this whole fraction would be 0, would be dividing into there, and then definitely that can't be 0 either. Okay, continuing on. So we're going to factor everything. And we don't really do division, we change it into multiplication. But we have to remember the restrictions come from these 3 parts with division. So I'm going to factor out a 3x here, so it's 3x, and then it'd be x minus 8. Down here I'm factoring out an x, so it'd be x plus 5. I'm going to flip it upside down and factor out an x, so it'd be x and then x minus 2 over 3x. So that's what I'm getting left. And then the restrictions, x cannot be 0. That would be here, here, and there. X cannot be 2, because 2 minus 2 is 0. And x cannot be negative 5. So there, the restrictions. Okay. Did I factor everything correctly? Yes, yes, yes. So now I'm going to hack things away. The 3x's go, the x's go. So I'm left with x minus 8 times x minus 2 over x plus 5. I'm going to go ahead and multiply those together. So it's x plus 5 on the top, and on the bottom, and then on the top here we have x squared. And this would be minus 2 and minus 8 makes negative 10x, and then those multiplied together would be positive 16. So there it is with those restrictions. All right, now I'm going to factor like a crazy fool. This factors into the difference of 2 perfect squares, x plus 5, and then x minus 5. This is x plus 3 and x minus 3 times, flip upside down. So this is now going to be on the top, x plus 2, x plus 3. And then now this is on the bottom, x plus 2, x plus 5. And then again, the restrictions come from here, here, and here, because this top here can't be 0, otherwise this whole fraction would be 0, and I'll be dividing by 0. So that's what's weird about that. Okay, so I need restrictions of 3 and negative 3. So x cannot be plus or minus 3. And then negative 2. And then negative 5. So those are the restrictions there. Now I can start hacking things away. Gone, 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 and gone. So the only thing that's left is x minus 5 over x minus 3, and then those are the restrictions. Okay, now we're going to add. We're going to add. When we add, we must have a common denominator, just like subtracting, we have to have a common denominator. So sometimes when I say fractions, I say top and bottom because they're faster to say than numerator and denominator, but so my language sometimes is a little sloppy, but you know, it is what it is. So I need to make these exactly the same. 4 and 5 have no common factors, so this one needs a 5. We multiply by 5 and 5. This one needs a 4, and that one needs a 4. And of course the restriction would be x cannot be 0, otherwise you'd be dividing by 0. So now these are both 20s, so it's this times this would be 12 over 20x, and then that would be 35 over 20x. So the denominators are the same. How did I make the denominators the same? By multiplying by 4s, by multiplying by 5s, and then those are exactly the same. So I have 12 things and 35 things make 47 things. Okay, in order to tell what we need to make them the same, sometimes we have to factor. So I'm going to factor this as x squared plus 2x plus 5 over factor plus 2x over x minus 5. So the only really way to tell what I need is by factoring that. So it's minus 3 and minus 5. So now I can see that those are the same, so this one needs an x minus 3. Since this has x minus 3 there, now they are exactly the same. The x cannot be 3 and 5, right? Because that would make each one of those 0. So x cannot be 3, x cannot be 5. Now we have x squared plus 2x plus 5 over the common denominator, which is x squared. I'm just going to multiply that back together, 8x plus 15, plus distribute 2x squared minus 6x over x squared minus 8x plus 15. Those are the same. Distributed, I did that correctly. Now I collect my like terms. I have 2x squareds here and 1 there, so I have 3x squared. I have 2x's minus 6x's. 2 minus 6 is negative 4. And then the 5 has no partner, so it's 5 over x squared minus 8x plus 15. Ba-boom. Okay, now we're going to subtract. Subtracting is the same thing, except for I subtract at the end. And did I get all my restrictions? Yes, I'm good with restrictions. Okay, number 13. These are kind of the same, except we're missing that part there, correct? So we need an x plus 4 on the bottom and an x plus 4 on the top. Now, when I distribute the 8, what I really need to do is distribute negative 8. And how do I do that? I add the opposite. And then that makes it easier to think about doing this problem. So it's x plus 2 over 5 times x plus 4 plus negative 8x and negative 32 over 5 times x plus 4. The only restriction here is x can't be negative 4 because negative 4 plus 4 would be 0. Then I put together my like terms. Negative 8 with the x would be negative 7x. And then negative with this would be minus 30 over 5x plus 20. And there's the answer there. Again, number 14 and number 12 are pretty much identical because we need to factor this in order to see what we need, because maybe we don't have to multiply those together. So x plus 2 over x and x minus 4 minus 7 would make the positive 28 and then the negative 11 in the middle. Minus 3 over x minus 4. So those are the same. We need the x minus 7. So I do x minus 7 on the bottom and the top. Again, we're going to think about this as adding negative 3 and then distribute the negative 3 through the parentheses. That will make it much easier to do. So we're adding the opposite. So we're really just turning this into an addition problem, kind of like how we changed multiplication into or division into a multiplication problem. So x cannot be 4 and x cannot definitely be 7 because that would create zeros there. So those are my restrictions. Then we go x plus 2. I know that times that is equal to that, so I write it down. And then distribute, plus that times that is negative 3x, that times that is positive 21 over the common denominator, which is just the first denominator multiplied out there. Okay, collecting my like terms, so x squared minus 11x is the common denominator, goes on the bottom. Like terms, negative 3, and then one more, that's 1, so it'd be negative 2x, and then 2, and then 21 added together is 23. So there's the answer to that one. Okay, now we're going to solve. These two problems here are pretty simple because we're just going to do the cross-multiplying situation. So this times this is 2 times x minus 4, and this times this would be just x minus 2, because 1 times anything is itself. When we solve this, x cannot be 2, x cannot be 4, because that would be division of 0 there. Distribute through. 2x minus 8 is equal to x minus 2. Subtract the x over, add the 8 over. Get the x's on one, and that's an 8, so 6, right? 6 should be the answer. This one here, we can't have plus or minus the square root of 2, so we've never really seen one like that before, because if we had the square root of 2 squared, that'd be 2 minus 2 is 0, and then x, of course, cannot be 0, because you'd be dividing by 0 there. Okay, cross multiply. Put it in parentheses. Put that in parentheses. Put your binomials in parentheses because you got to distribute. So it's going to be 4 times x squared minus 2, and then it's going to be x times x plus 10. So it's going to be 4x squared minus 8 is equal to x squared plus 10x. Okay, this is a quadratic. How do we solve quadratics? We set them equal to 0, and then we factor or do the quadratic formula. So I'm going to subtract over the x squared. I'm going to subtract over the 10x, so I can set this equal to 0. That makes 3x squared minus 10x, and then make minus 8 is equal to 0. So that came down here. That doesn't have a partners here, but we put those together and it goes there. Okay, so now we have to make 10 in the middle. 3x and x, and then we need to make a 12. So the 12 needs to be negative, and then 2 here positive. So that would be negative 12 plus 2 is negative 10. That time, oh, it works. It works. 0 product property. X minus 4 is equal to 0, so x is equal to 4, because 4 minus 4 would be 0. And then 3x plus 2 is equal to 0. Subtract the 2 over. 3x is negative 2. Divide by 3. X is negative 2/3. Okay, last page. Woohoo! Last page. Number 17. Number 17 is clear the fraction problem. Again, x cannot be 0 on this one. X cannot be 0 because you would cause division of 0. So we did this method of clearing the fractions with the LCM. So I'm going to multiply everything by the LCM. Well, 2 and 9 don't have any common factors, so 18 would be the LCM for 2 and 9. Like if I count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, then count by 9s, 9, 18. So 18 is the LCM, and then x squared, right? That's x times x, and so everyone would have to have an x squared. So there's the LCM, so I'm going to multiply it through. So it is 18 times 1 on each one of those. So it's 18x squared over 9. 18 times that. So it'd be 18x squared over 2x. And then it'd be times the 1, it'd be 18x squared over x squared. Why do we do that? Because it kills the fractions. 9 goes into there 2 times, so it's 2x squared. 2x goes into here, that would be 9. And then x goes into there, leaving x, right? And then the x squareds cancel 18. So now I have this nice quadratic, set it equal to 0. 2x squared plus 9x minus 18 is equal to 0. 2x, x. I believe this factors 6. That would be 12. And the 12 needs to be positive, and then minus 3x would make 9 in the middle. So that would be negative 18, it would be 12 minus, yep, that's how it factors. 0, product, proper, t. So it's x plus 6 is equal to 0. X is negative 6, of course, because negative 6 plus 6 is 0. 2x minus 3 is equal to 0. So we're going to add the 3 over, so we get 2x is equal to 3, x is equal to 3 halves. Okay, last one of the solving things. Factor this out. This is x and then x plus 3. So each one of these needs an x. So there's an x there, an x there. That would need an x. This has an x plus 3. That has an x plus 3. That would need an x plus 3. So the LCM is x times x plus 3. We're going to multiply that all the way through. For our answers, x cannot be 0 and then 3, right? Negative 3. X cannot be negative 3 because that would cause division of 0. So I'm going to distribute this all the way through, and I'm going to change that into that. So it's going to be 3 x times x plus 3 over x times x plus 3. So that'll all cancel out. Plus x plus 2 over x plus 3 times x plus 3 is equal to 1 over x times x plus 3. Okay, now, so the x plus 3 got distributed through to all the parts. Cancels out, leaving 3. Cancels out, leaving x times x plus 2 equals. Cancels out the x's, x plus 3. Okay, this is going to be a quadratic in a second, so boom, ba-boom. So it's x squared plus 2x, and then plus 3 is equal to x plus 3. So I'm going to subtract 3 from each side and subtract x from each side, because when you solve quadratics, you got to set them equal to 0. So it's x squared plus x. Now this kind of factoring here is taking out the common factor. 0, product, proper, t, x equals 0, x plus 1 is equal to 0, x equals negative 1. Now there should be a warning light going off in your head, auga, auga, whoop, 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 because x can't be 0. So that means this is the extraneous solution. X is negative 1. Okay, Paul can paint a room in 5 hours. Peter can paint a room in 9 hours. So this is just that one job can be done in 5 hours. One job can be done in X hours. So that's the situation here. We're going to multiply by the LCM. Obviously, x can't be 0 because they can't do the painting instantly. So the LCM would be 9 and 5, which is 45, and then x. So it's 45x. So 45x over 5, distributing through, 45x over 9, and 45x over x. So then the 5 goes in there 9 times, so it's 9x plus goes into there 5 times. 5x is equal to 45. 14x is equal to 45. Divide by 14. The answer has to be less than 5 hours because Paul will help out Peter. Wonder where Mary is. Peter, Paul, and Mary, right? That was a Peter, Paul, and Mary joke. So it's 14 blah, blah, blah hours. 45 over 14. So I'll do the decimal for that. So it's 45 clear. 45 divided by 15 is, not 15, 14, my bad. 14. So 3.21 hours. Approximately. Okay. Okay. So there's the answer to that one. Well, congratulations, you made it through this. This is a pretty long video, so you'll have to do it in chunks.